Ladies and gentlemen, we are about to begin our opening ceremony. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. On behalf of the organizers, we would like to extend our warm welcome to all the guests to Mini Symposium on the current progress of Mathematics and Natural Sciences 2023, being hosted by the Faculty of Mathematics and Natural Sciences, Universitas Indonesia, in collaborations with the Faculty of Science, University Malaya, on January 31st, 2023. My name is Tessa, and I will be your Master of Ceremony for today's Mini Symposium. In this occasion, I would like to welcome our honorable guests, the Dean of Faculty of Mathematics and Natural Sciences, Universitas Indonesia, Bapak Dede Juhana PhD, and the Dean of Faculty of Sciences, University Malaya, Prof. Dr. Zulkarnain Mohammed, who are here with us through the Zoom link. I would also welcome the Vice Deans of Faculty of Mathematics and Natural Sciences and Faculty of Natural Sciences from Universitas Indonesia and University Malaya. Our keynote speakers, Prof. Budiawan from FMIPA UI and Prof. Dr. Muhammad Sufyan from Faculty of Sciences, University Malaya. And we also welcome all the lecturers from FMIPA and Faculty of Science, guests, students, and all the participants. Thank you everyone for joining our mini symposium today. Ladies and gentlemen, to begin with, I would like to invite Bapak Dede Juhana PhD as the Dean of Faculty of Mathematics and Natural Sciences, Universitas Indonesia to deliver his remarks. Bapak Dede, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera bagi kita semua. Om Swastiastu, Namo Buddhaya, salam kebajikan. Good morning everybody. In this session, we appreciate Excellency to Dean Professor Dr. Zulkarnain Mohammed and Deputy Dean of Research, Professor Dr. Azhar Arifin, and all other Deputy Dean of Faculty of Science, University of Malaysia. And thank you for Professor and for Head Department, and also lecturer and researcher who attend this workshop. Governing everyone who is present in this amazing symposium, whether it's offline in the Malaysia and Indonesia or online with via Zoom. First of all, I would like to thank the Dean of Faculty of Science at the University of Malaya who has accepting our invitation to hold in this symposium together. I also would like to thank in advance all the organizing committee from Universitas Indonesia and University Malaya who have organized in this conference on a hybrid base. Dear colleges, professor, lecturers, researchers, study, ladies and gentlemen, on behalf of the Faculty of Mathematics and Natural Science, University of Indonesia, I would like to express my sincere gratitude and welcome to your this mini symposium and current progress and mathematics and natural science. In this international joint symposium is the collaboration between the Faculty of Science, University Malaya, and the Faculty Mathematics and Natural Science, Universitas Indonesia. It is a wonderful moment that we can get know one another in this excellent occasion, where we can share our knowledge one another and see future prospect and collaboration. Through this wonderful moment, allow me to briefly introduce to our Faculty of Science in the University of Indonesia. Faculty of Mathematics and Natural Science, University of Indonesia consists of several departments such as mathematics, physics, chemistry, biology, and geography, and also geoscience. With more than 3,000 students, 100 of researchers and lecturers, we established our position as on the leading scientific institution in Indonesia, where the most our study program have been accredited internationally and achieved good results. Many of research topic development in our lecture have been used in the mine sector industry, and recently we have 5 our lecture have been awarded up to top 2% scientific in the world in the 2022. As the further commitment on the collaboration, we are humbly invite the Faculty of Science, University of Malaya to hold this joint symposium in Bali in August 30 to September 1 in the 2023 in Bali, inshallah. This conference is annual conference held by our faculty called ESPMS. It is our pleasure if you can join us whether as co-organizer or as participant in this conference. Finally, I hope that the joint symposium, we can give the great benefit to foresight in the University Malaya and Universitas Indonesia. We hope that will be the first step for possible collaboration in the future between our university. We hope to see you soon personally, whether you can come visit us in University Indonesia or we come to visit you in Malaya. Have a great symposium. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak Dede, for a meaningful speech. Now let's come to the second agenda. Allow us to invite Prof. Dr. Zulkarnain Muhammad, the Dean of Faculty of Science, University Malaya, to deliver his remarks. Prof. Zulkarnain, time is yours.
Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm not sure where to look. Right, salam perkenalan kepada semua warga di Universitas Indonesia dan selamat datang kepada joint symposium of joint mini symposium on the current progress in mathematics and natural sciences. I'm Prof. Zul, the Dean of Faculty of Science, and please allow me to take a few minutes to introduce to you the University of Malaya, and the Faculty of Science. Next slide. So a little bit of a history of University of Malaya. It is started off in Singapore with King's College and Raffles College. And then these two colleges were combined to become the College of Medicine. And then around the 1960s, it was separated again into what is now known as the National University of Singapore and the University of Malaya in Malaysia. And you are actually looking at one of the oldest university, in fact, in Malaysia. And University of Malaya, one of the first faculties in University of Malaya is the Faculty of Science and Faculty of Engineering and Faculty of Medicine. Next slide. So in the University of Malaya, we have 17 academic institutions. We have 14 faculties, 2 academies, and 1 academic center. But these numbers fluctuate because in the current management, there are some merging and there's some with progress. We are making a lot of changes. But in total, we have about 30,000 students with a ratio of about 2 undergraduates to 1 postgraduate. We are a comprehensive university. So we have all the different fields in our university. We have about 4,500 international students, and this is both for undergraduates and also the postgraduate degrees. Next slide. So these are some facts. We are known for as the best teaching hospital in the country. We have the largest number of beds. We are the top rank as well. Alhamdulillah. We strive to maintain this position, and hopefully we aspire to become one of the best universities in the world. I would like to show you some of the, we welcome a lot of collaborations. And when we talk about collaborations, it's not just about sharing and information and research. I'll show you in a bit that there are various ways that we can actually collaborate between Universitas Indonesia and ourselves, University of Malaya. Next slide. Again, this is just some facts about our ranking. Next slide. Next. I want to go into, okay, so here you go. These are the different faculties in the University of Malaya. 14 faculties, 2 academies, and we are we are number 13. Well, not in terms of rank, we're just alphabetical order. Next. We have about 266 international staff, and they come from all over the world. Next. This is our undergraduate international students, international undergraduate students. Next, again, this is international postgraduate, the next slide. And then next slide. So this is what I want to show you is the one possible arrangement, one of our collaboration with the university in France is the Languages and Civilization University, where it is a joint degree between these 2 universities. The students do about 4 years, 2 years here doing the language, French language, and then later on they learn about, they will be doing the didactics, teaching of French as a second language. This is our program with the University of Language and Civilization in France. And on the right side of the slide is our collaboration with Constance University of Applied Science, where they do, again, the French language here, and then they move on to do business, German and tourism management. So these are some of the examples that we can collaborate with between UM and UE. Next one. These are dual masters between ourselves and University of Osaka, and from Kyoto University, and also from American University of Technology. So, and this is on coming up with a dual masters program. And next slide. And then this is also collaborative PhD programs. We can call it dual where you have the 2 degrees, or joint, we have 1 degree, and also some split site programs where the research is actually done in both universities. So the possibilities are quite endless. Just moving on, because I don't think, on the bit of Faculty of Science, I think more will be elaborated by the Deputy Dean, but basically, next slide. This is just our position. This is a very old picture where it shows that the yellow region is actually where the Faculty of Sciences is way back in the 1960s. And on the left side, this is where we are at the moment of progress. Next. Oh, there's just too big of me. We have 6 departments: Institute of Biology, Institute of Mathematics, Department of Physics, Department of Chemistry, Geology, and Department of Science and Technology Studies. So, and then I think after this, we'll have the breakup rooms where each of the departments will be sharing their research. And these are some of the individuals for your information and for your contact later on. Next slide. All right. Next slide. Okay. Just some details here and there. I think we will be more than happy to provide you with the slides, but I think what's important is towards the end. Can you move on to the next slide? Further, these are the different programs that we have. I think what will work, what is necessary when we talk about working together, is knowing the strengths and the gaps that are prevalent in each of our universities. And that way we can actually work together and complement each other. So what we have, can we go on to the slide where we have the expertise, where we will provide you with, move on. Yeah, carry on. Oh, you didn't have the extra. Oh, all right, it's okay. Later on, we will provide you with the keywords, I think, with our Deputy Dean, between where we know each of our strengths and also the gaps that we can perhaps be working together, because gone are the days that researchers are working on their own. We now have to work together in a multidisciplinary nature so that we can prosper and then do more meaningful science in the currently progressing area that we are in the moment. Congratulations to both sides of the organizing committee for coming up with this symposium, and I wish you all a very fruitful discussion and meeting. Assalamualaikum. Thank you very much.
Thank you very much, Prof. Zulkarnain, for a meaningful speech. Ladies and gentlemen, now it's a photo sessions. We will have separate photo sessions. So for all of you, for all of the guests, which is here in Universitas Indonesia, please raise from your seats, and then the organizing committee will take a photo from the front side. And then for everyone, for all the guests in the Zoom meetings, you can turn on your video and please hold it for a moment. The host will capture the moment and it will take a few seconds. Thank you so much. So, honorable guests, ladies and gentlemen, before going further to the plenary sessions, allow me to invite Professor Dr. Ernard Budiawan from Faculty of Mathematics and Natural Sciences, Universitas Indonesia, to deliver the research focus in FMIPA UI. Prof. Budiawan, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. The Honorable Dean of Faculty of Science, Professor Dr. Zulkarnain Mohammed, and Deputy Deans of Research, Professor Dr. Azhar Arifin, and all the Deputy Deans in Faculty of Science, Universitas Indonesia. Very good morning. Nice to see you. Nice to meet you in this occasion. And then also we would like to greet honors to our deans, Dr. Dede Johanna, and also all the head of department and manager in Faculty of Mathematics Universitas Indonesia. Now we would like to show you about our profile in the Faculty of Mathematical Natural Science. Okay, next slide. Please move on. Okay, now the fact of our faculty, we founded in 20 December 1960, and we have 6 departments: mathematics, physics, chemistry, biology, geography, and geoscience so far. And then we have also 20 study program, consist 9 undergraduate program we have, and also 8 magister and 4 PhD program. And also we have 20 professors in our faculty. Located, our faculty is 2 campus in Depok, in central neighborhood Jakarta, and Salemba, discussed in Jakarta. There's 2 campus that we have for our faculty. So far, we have more than 5,000 students, 4,100 undergraduate students, and we have also 582 master program. And now we have so far 118 doctoral programs, more than 150 courses we have in our faculty, and 168 academic staff we have, and also 164 employers. So more than also we have the alumni, 23,000 roughly. What is? Move on next. Ladies and gentlemen, this is our location of Faculty of Mathematics and Natural Science. This is focus is located in Depok, central of West Java. Okay. Move on. Now, our faculty, we have period 2022 until 2025 as Dean, Dr. Dede Johanna, PhD, and Vice Dean of for Education, Research, and Student Affairs, myself. And also we have Vice Dean for Research Venture and General Administration. That means we like collaboration with Dr. Tito Latif Indra. Move on. And out of the faculty leaders, we have a Manager of Education, Dr. Rika Triyunarti, Manager of Research and Community Service, Dr. Dipo Aldila, Manager of Student Affairs, Dr. Dewi Susuloningsias, and Head of Academic Quality Assurance Unit, Dr. Denny Ersilaban. This is manager under Vice Dean Affair. I mean, Vice Dean 1 in our faculty. If you are to be connected and more creative collaboration, I think you can contact them, and you can find also in our website. And we have also under Vice Dean 2, under Dr. Tito Latif, we have Manager of Collaboration Venture and Alumni Relation, Dr. Lukmanda Evan Lubis, General Manager and Facility Muhammad Hidayat Social, and we have Manager of Human Resources, Fakhur Rizi, Masters of Social, and we have also Chief of Secretary Erning Stiono, Master of Science. Now, so far we have, as I mentioned before, we have 6 departments. I mean that we have Department of Mathematics. This is head of department, Professor under Professor Al Hadi Bustaman, PhD, and Department of Physics, Dr. Jati Handoko, head of departments, and Dr. Asep Saipumula, head of department Chemistry, and Anom Bawas Laksono, PhD, as head of department of Geology. And we have also Dr. Supriyatna, head of department Geography. And last, we have head of study program, Dr. Ing Supriyanto. Under this department, we have undergraduate program like mathematics and also statistics, actuaries, and also magister for mathematics. And under the Department of Physics, we have undergraduate physics, master physics, material science program master, and we have also medical physics from program master and also material of science. And last, we have also program doctor for physics in this case. In our Department of Chemistry, we have undergraduate for chemistry and also for magister and also for doctor program. In our department of biology, we have also undergraduate biology, magister biology, marine science, and doctor science in this case. Under the Department of Geography, we have undergraduate geography study program, and also we have magister geography study program. And last, for undergraduate geophysics, we have also undergraduate from study program about geography. Okay, move on. Ladies and gentlemen, now I would like to also show you our vision and mission. I think all the vision and mission is related to our vision in UI, I mean the University of Indonesia. That means our mission and our vision to serve as leading scientific institution in mathematics and natural science capable of playing a role globally to promote science and sustainable development. Okay, next. So under UI, under Universitas Indonesia, we have also foreign student program for our faculty. Since 2022, we have UI grade program. That means a program that could be, we have the scholarship program also from KNB, that means for our Minister Education, KNB program development country, perhaps. First, partnership, I mean it. So far, we have 14 student foreigners in our faculty. Okay, next time. Ladies and gentlemen, so far we have also cooperation, focusing not only academic cooperation, but we have cooperation, non-academic cooperation. So far we have totally 435 cooperation and 20 active cooperation, even national and also international cooperation so far. So about the collaboration, research cooperation, we have also with other institutions like Ministry of Industry, Ministry of Science, and also with other private sector, we have also the collaboration research in this case. Thank you, and then next. Now we're focusing about the research in our faculty. The focusing research we have under the University of Indonesia. So far we have 5 division in focusing research in University of Indonesia, especially about health and welfare and new energy sustainable, and also about the community investment, and also about the environments, and also about the safety and security in our faculty. This is 5-term program focusing in our Universitas Indonesia. Focus in our faculty. Next slide, please. Based on the research focus directed by University, Faculty of Mathematical Science, University of Indonesia focus on the following topic, as I mentioned before, that we have 5, and then we have delivered for the research program from artificial intelligence of health, artificial intelligence, actual science, and so on, and also about the chemical toxicology, nano chemistry, and so on. And we have also modeling and in count, nucleon, and hadron production. And other, we have focus also implementation of remote sensing and so on. This is the focus so far in our faculty. Next one. Ladies and gentlemen, this I would like to show you about the recent cooperation visit during the collaboration between our faculty and other institution. Okay, next one. And also we have the latest collaboration with PTNGA that meant about collaboration about focusing research on palm oil research. We have collaboration with a private company to develop the trend that added value for sawit. I mean that from palm oil research in this case. Okay, thank you. Next. About our community, so far we have also collaboration with Japan company. This is a program that we have a collaboration with Python, Python Energy. This private company for Japan to make the composting and also new energy, sustainable energy in our program, the community as service in our faculty. Okay, next. This is also by products, I mean that for our cooperation with Python Energy. We have, as I mentioned, we have produced a composting and liquid and solid compost that also use in the fertilizer as fertilizer, and also they use also as products in community in this case. Okay, next. Ladies and gentlemen, the future research products of our faculty, Mathematics and University of Indonesia, we have product. I think this is AWAS. We call AWAS this earthquake warning alert system, have a sticker imaging, telemedicine, and also spatial information system and village maps. This is what we have featured the research product of our faculty so far. Next. About our facility in our faculty, we have also mathematics laboratory, physical laboratory, chemistry laboratory, biology laboratory, under geography laboratory, and geoscience laboratory. Not only for undergraduate, we have also laboratory for research program and also for PhD program. And we have also center of research in UI in I mean that the integrated laboratory central in our university, besides the laboratory that we have in our faculty. Okay, next slide. Now, I would like to show you about the collaboration lab with Petromer Chemical and Life Science. So far, they have built up our laboratory in Department of Geology, and the collaboration lab, Life Science instrument, they also include in our collaboration. The research equipment, we have environmental monitoring, microbiology, immunology assay, protein detection, general lab instrument, and more. Okay, next one. Under do we have activity? I mean, the academic activity in our faculty of science, we have also Institute of Applied Science. We call it LST in our faculty. The head of LST is Professor Yana Supriyatna, PhD, and the vice head of LIS faculty, FMIPA, Eko Waludi, Master of Science. In this Institute of Applied Science, we have Center of Geoscience Study, Center of Applied Geography Research, Data Science Center, Research Center for Climate Change, Artificial Intelligence Center, AISAI, and also UEChem. We have also Center for Study of Material Science and Industrial Palm Oil Innovation Research Center. So far. And also the equipment, and we have also in our faculty use service that meant for the community. We have collaboration also lab for service for collaboration with other institutions in this case. Okay. Thank you very much. This is our logo, leading in research and innovation. We hope that collaboration with University of Malaysia FC for Faculty of Science will be good collaboration and good for the future. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Prof. Budiawan. Next, I will invite Professor Dr. Azhar Arifin from Faculty of Science, University Malaya, to explain the research focus on Faculty of Science, University Malaya. Prof. Azhar, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Selamat pagi semua. Yang saya hormati Profesor Didi Johana, Dekan Fakulti Matematika dan Ilmu Pengetahuan Alam Universiti Indonesia. Yang saya hormati Profesor Dr. Zulkarnain Muhammad, Dekan Fakulti Sains Universiti Malaya. Yang saya hormati juga Vice Dean for Education, Research and Student Affairs, Profesor Dr. Budiawan, rakan-rakan daripada Universiti Indonesia dan juga daripada Universiti Malaya. Selamat datang dan terima kasih atas kesudian semua untuk menyertai mini simposium yang dianjurkan bersama di antara Universiti Malaya, Fakulti Sains Universiti Malaya dan juga FEMIPA Universiti Indonesia. Okey, disebabkan struktur organisasi antara UI dan UM agak berbeza, di pihak Universiti Malaya di bawah Fakulti Sains, Deputy Dean ataupun Deputy Dean of Research only take care of research affairs. So my slide today or my talk today will focus more on the research that we have here and all the activity research focus that we have in our faculty. So now under Research Management Unit, now we call it Science Excellence. It's our new name actually, just still hot, just introduced last few weeks. So we call it Science Excellence, which is a part under Research Management Unit. Okay, as shown by the Dean just now, so to cut the history short, the Faculty of Science was established in 1959. Before that, the long story was started in Singapore. So the Faculty of Science is a highly accomplished center of learning and research within the university. It commands excellence in frontier scientific endeavor, covering knowledge enhancement, advancements, fundamental to impact-oriented applied research. So under Research Management Unit, so my unit taking care of the research grant management. So we're promoting if there is opportunity of research funding. We also looking for possible funding from international, okay, in Malaysia and outside of Malaysia. We also in charge of the bilateral partnership development in the, I think, collaboration with our new Deputy Dean. We now have value creation. So this bilateral partnership, I think we have no choice. We will work with the Deputy Dean of Value Creation. And we also fostering research ecosystem and support. We also coordinate research output, and then the main thing is the publication management. So we from time to time help our staff members to publish their research output in mainly WOS publication, or used to call it ISI, and also some also in the Scopus publication. Okay. And then we in our Faculty of Science, we have our own journal. We manage our own journal. We call it Malaysian Journal of Science. This is a Scopus Index journal. So we are welcome our counterpart from UI, UI. I hope I pronounce it correctly. to send their manuscript to be published in our Malaysian Journal of Science. So that is basically the role of research management unit under my jurisdiction. Okay. Initially, when Faculty of Science was introduced, okay, our focus was primarily on scientific advancements toward fundamental and single disciplinary research. We have overlooked the importance of multidisciplinary and interdisciplinary research. So that was our initial focus. But now, today, we have realized that our potential and have shifted our paradigm to foster science, environment, and social pillars aligned with the emergence of the environmental sustainable goals and other sustainable approach. So from single discipline, now we move on to have a multidisciplinary research. So that is our focus now, and also that is in line with our government policy now. We are encouraged to join into a more multidisciplinary research instead of just focus in a single discipline. Oops. Okay, this is among a few of our research trust area that we have in our Faculty of Science. We have natural resources and energy, mainly researcher from Institute of Science, Biological Science, Geology. We have subsurface geology. We have bio-inspired frontiers, sustainability science, natural products. We have theoretical and computational science. We have water and environments, photonic and optics, health and wellness, biodiversity, cryptography and data security, advanced material. We have also stellar and extragalactic astrophysics, data science, and also STI policy and management. So there is a few that I can show here that the research trust area in the Faculty of Science. We also have other research that is going on in our faculty that I don't have enough space to put on the slide here. So maybe after this we can communicate. And also in the afternoon, we will have the breakout room. So each department will have more opportunity to explore what are the research that is going on in each department. So I hope everybody will take the opportunity in the breakout room during this afternoon to explore more possible collaboration between the two faculty of the two university. A little bit of information of our achievement for last year in 2022. Last year, we managed to publish about 729 publication in Web of Science publications. And we also published about 821 in Scopus Index Journal. And then our staff also have submit or file 17 patents. And we have about 16 research center. And then out of 729 of the Web of Science publications, 75% are published in the Q1 and Q2 index journal. And then overall, if we calculate per staff, so basically about each of our academic staff published 3.1 papers. So that is on average, of course. Some publish more than that, some publish less than that. But on average, our staff published about three papers for 2022. And then in terms of research funding, so this is the current active funding that we have. So in total, at the moment, we have about 63 million. So this 63 million ringgit Malaysia, the funding comes from international grant, about 4 million. And then from the public, meaning that from the government, about 51 million. And we also receive some funding from the private or industrial, which is about 7.7 million. So in total, currently, we have about 63 million of research fund to support the research that we have in our faculty. Okay, now we move on to more specific, looking at the department that we have in our faculty. So first we look at the Institute of Biological Science. So we have at least 12 different research areas. So these include life sciences, environment and sustainability, ecology, biodiversity, biochemistry, microbiology, genetic, biotechnology, agriculture, health science, livestock, and bioinformatics. So for more detailed information, I think those who are interested to collaborate with researchers from Institute of Biological Sciences, they can join the breakout room with the Department or Institute of Biological Science this afternoon after our lunch break today. Next is Institute of Mathematical Science. So we have at least 13 different research areas. So these include mathematical modeling, we have social network analysis, cryptography, we have operational research, algebra, combinatorics, geometry, and topology. We have statistic modeling and inferences, data analytics, statistical consulting, actuarial science. So this actuarial science is one of the very highly demand courses in the Institute of Mathematical Science. And then we also have mathematical finance and economics and actuarial statistics. So again, so for those who are interested to join or collaborate with a researcher from Institute of Mathematical Science, or in short, we call it ISM here in UM, so they can join the breakout room this afternoon with the mathematical science. So for the departments of physics, this our top published journal in our department. So Department of Physics have the highest ratio of publication among the researcher. So they have at least 8 different research areas. These include astronomy, high energy physics, material science, solid state physics, theoretical and computational physics, plasma, quantum and laser, and also radiation. And then for Department of Chemistry, we have about 17 different research interests. We have organic synthesis, drug design, we have natural product, drug discovery, we have physical science, which include colloid chemistry, liquid crystal, and surfactant. We have those researchers working in nanomaterials, okay, such as nanoemulsions. We have analytical chemistry for method development, Raman spectroscopy, and separation technologies. We have researcher on environmental chemistry, water quality testing, and soil analysis. We have polymer composites, polymer chemistry, polymer materials, polymer synthesis and characterizations. We also have researcher working on biosensor, electrochemistry, ionic liquid synthesis, rubber chemistry and composites, coordination chemistry, medicinal chemistry, solid state chemistry, bio-inorganic chemistry, and also X-ray crystallography. For Department of Geology, we have at least 6 different research areas. We have earth, materials, and mining geology. These include the rare earth element. This is among the current trend for our government to explore in the rare earth element. So for those who are interested in the rare earth element, then they can contact our researcher from Department of Geology. Other than that, we also have petroleum geology, engineering geology, hydrogeology, environmental geology, and also geophysics. Okay, this department that maybe we don't have the counterpart in UI. We call it Department of Science and Technology Studies. So under this department, we have 9 different research areas. We have science and public policies. We have technological innovation management. We have history and philosophy of science, science communication, environmental protection, ethics in science, science and religion, critical thinking, food security, and safety. So for your information, that this Department of Science and Technology studies basically doing more on the policy study that related to science. Okay, other than that, we have a research center. We have several different kind of research center. One of them is Higher Education Center of Excellence, high COA. This one is the national level of research center. But since the researcher is coming initially from our faculty, so I put it here. So for those interested on research on Photonic Research Center, so we have this under what we call it high COE. And then we have research cluster, Frontiers of Natural World. So under this cluster of Frontiers of the Natural World, we have research center such as Mushroom Research Center. We have Low Dimensional Material Research Center. We have Center for Ionics, University of Malaya, Plasma Technology. We have Center for Fundamental and Frontier Sciences in Self-Assembly. We have Center of Research in System Biology, Structural Bioinformatics, and Human Digital Imaging. And we also have Center for Mathematical Modeling and Optimization. We also have University of Malaya Center for Data Analytics. Okay, and then there is another research cluster that is available in or University of Malaya. We call it Innovative Industry and Science. We have one research center that is linked to our faculty. We call it University of Malaya Center for Ionic Liquids. I think this center for ionic liquid, I think we have some collaboration with university in Indonesia, but I can't remember exactly which university, because we have many collaboration with university from Indonesia. Okay, this is among research center that is directly part under Faculty of Science. So we have Biodiversity and Ecological Research Network. We have Quantum Science Center. We have Geoscience Research Center. We have Center for Research in Waste Management. We have Center for Theoretical and Computational Physics, and also Center of Research for Statistical Modeling and Methodology. So we have a lot of research center. So if you would like to know more detail, I think some of these research center under specific department. So maybe in the breakout room later on, the head of department will explain more detail about all these research center that is related to each department. So this is the maps about our partners we currently have. So this is for Faculty of Science. We have signed about 100 MOU, and then we have 91 Memorandum of Agreement. So the blue color country that we label that is where the country that we have collaboration. Okay, either MOU or MOA. So for sure that you can see that we have a lot of collaboration with the University of Indonesia. We have either in Sumatra, in I don't know why the Java Island is missing there. Okay. Our engagement with the internal and external stakeholders has evolved over the years. Earlier, and also interdisciplinary research ecosystem. So our approach is either bilateral or trilateral. So what I mean by bilateral is that our researcher from Faculty of Science, we collaborate either with the industry or with the governments or governance. We also that we call it bilateral research, and also we have a trilateral where we combine Faculty of Science, our researcher from our faculty, we work with industry and also with the governance. So this is some of the requirement actually for certain research funding that available in Malaysia, especially some funding from the ministry. They required us to work with industry and also the government. So we have to partner with the industry, then only we can ask for certain kind of grant. And normally this grant is come with big money. So in order to get big amount of research funding, we have to collaborate with the industry. Then only we can ask for a big money from the governments. Okay, one of some of the reason for collaborations or partnership with other institutions, either local or international, is service and training. So we would like to exchange service and also training. Either we send our staff to train, to be trained at the other institution. And also we would like to share sharing expertise that we have. Okay. And then also joint grant application, sharing of resources. So whatever instrument that we have, we can share with our collaborator with other institution. And then we have consultations. We can also arrange for guest lecture for undergraduate and postgraduate course, or maybe some other kind of lecture, joint supervision, research collaboration, staff attachment, and student attachment. So this is the some of the things that we are looking for from this mini symposium. I hope that after our mini symposium today, we can start to initiate, at least we start with the guest lecture or joint supervision between the two faculty. And then later on research collaboration and also staff attachment. So for those who either we go to UI to do sabbatical, or UI staff come to University Malaya for the sabbatical attachment. This is some of the our highlight, our research findings. So recently, our researcher, Dr. Juan Carlos Algaba, involved in the first visual of the black hole project. This is a multi-national research collaborations with about 200 researchers working on this. And then this became, I think, a hot topic last year, I guess. And then our researcher also have identifications of dinosaur fossil in Malaysia. I think this work by the researcher from Department of Geology. Okay, this is also from Geology, discovery of new Tegodon fossil. I don't know if I pronounce it correctly. Okay, so this is also the work from a department, researcher from Department of Geology. And then this is some highlight of the output. There is many other highlight that because of time constraint and also the limited space that I can put, so I just highlight some of the finding that I mentioned just now that been put in the newspaper. And then this is some of facilities that we have, research and dedicated facilities. We have a very nice rimba ilmu in our main campus here. This has been gazetted as Warisan Kebangsaan under the Akta Warisan Kebangsaan 2005. And then in our faculty, we have Zoological Museum. So those who visited us here, then I think those who are interested in Institute of Science, Biological Science, they should visit this Zoological Museum. We also have a Gombak Field. This is a research center for those doing research in biology. Okay, we also have some scientific instrument like GC, LC, and then we also have in our Department of Geology, the Geological Museum, and then we have Glammy Biotechnology Research Center. This is outside from Kuala Lumpur, I think about 90 to 100 kilometers from the main campus here. This is where we are doing agriculture. So all sort of biotechnology kind of research we do in this Glammy Biotechnology Research Center in collaboration mainly with the Institute of Biological Science. So maybe those who are interested to know more about this Glammy or researcher that involved here, then you can join the breakout room with the Institute of Biological Science later on. Okay, some research instrument that we have working currently. We have MicroCity at the Department of Geology. We have PXRD at Department of Chemistry, Geology, and Physics, if I'm not mistaken. We have several units. I think we have 4 units of nuclear magnetic resonance. One of that I show here is the FT-NMR is at 400 megahertz. We have FT-NMR 600 megahertz as well. And then we have FESM in the Department of Chemistry, and also we have 1 unit of FESM in Department of Physics. So this is the two instrument that is also highly used in our faculty, apart from the FT-NMR. So FT-NMR is highly used by the researcher in the organic chemistry and also nature product. So this is some facility that we can collaborate to use together if we have research collaboration. And then some of the award achieved or received by our academic staff. Last year, we have Associate Professor Dr. Ahmad Suhaimi Abu Bakar, who received the academic staff with highest external research funding. So for your information, I think last year, Dr. Suhaimi received nearly 15 million of research funding from the Ministry of Science. And then we have excellent young researcher in science, Associate Professor Dr. Muhammad Fakhrul Zamani. And then we have our distinguished professor, our senior professor, Professor Dr. Ramesh, who received distinguished researcher in science. And then we have Professor Dr. Subha Basu, who received a book publication in science. And then last but not least, I would like to promote our own journal, Malaysian Journal of Science, as I mentioned earlier. So this journal was started since 1972. So we publish 3 times per year. We have 3 issues per year. And then currently is a Scopus Index and Q3 under QT. We are working hard with this journal, try to get this journal to get promoted to WOS publication. So at the moment, it's still under Scopus. So everybody or our counterpart in University of Indonesia are welcome to submit their manuscript. This is a open access journal with a very low fees. I think it's about 50 US dollar only, and then it's open access. You can access everywhere in the world. So that's it from me. Terima kasih. Thank you so much. So I hope I have shared some important information. So for further information regarding to research activity in our faculty, you can contact my my unit. I think Dr. Dipo can contact Mr. Tinesh, and also can email directly to me. So with that, I thanks everybody for your attention. So I hope this symposium akan membawa kebaikan kepada kita bersama untuk peluang kolaborasi pada masa hadapan. Sekian. Wabillahi taufiq wa hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Prof. Azhar, for such a very interesting topics regarding the research focus on the Faculty of Science, University Malaya. So, honorable guests, ladies and gentlemen, in a very short moment, we would like to start the first plenary session. Our first keynote speaker is Professor Dr. Rernat Budiawan from Department of Chemistry, Faculty of Mathematics and Natural Sciences, Universitas Indonesia. Prof. Budiawan will present the topics entitled Living with Health Risk in a Chemistry World. Without any further ado, I invite our moderator, Dr. Muhammad Ridwan from Department of Chemistry, Universitas Indonesia, to lead the discussion. Pak Ridwan, you are kindly requested.
Ya, terima kasih MC. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to the mini symposium, the current progress of mathematics and natural science 2023. The Honorable Dean and the Vice Deans, Faculty of Mathematics and Natural Science, Universitas Indonesia. The Honorable Dean and Deputy Deans, Faculty of Science, University Malaya.
our speakers, distinguished participants, ladies and gentlemen. Let me introduce myself. My name is Ridwan. I am from Department of Chemistry, University of Indonesia, Universitas Indonesia. It's a great pleasure to be here as a moderator in the plenary sessions. So without further ado, let me introduce our speakers, keynote speakers, which is the first speaker is Professor Budiawan to present the living can you yes, can you show that? Raising awareness the hazardous chemicals on health risks. We welcome Professor Budiawan to come upstairs, please. And let me introduce Professor Budiawan, please. Next slide, please. Okay, Professor Budiawan here got his doctoral degree in 1998 at Institute for Toxicology, Würzburg University in Germany. And currently he held a position as a Vice Dean Academics in Faculty of Mathematics and Natural Science. So without waiting for any longer, so I will welcome for Professor Budiawan to give his talks about raising the awareness of hazardous chemicals for health risk. For Professor Budiawan, the time is yours.
Thank you, Mr. Moderator, Dr. Ridwan. Good morning, ladies and gentlemen. This is Honorable Dean, Faculty Mathematics, Natural Science, Professor Dr. Dede Juana, and the Honorable Deans from Faculty Science and University of Malaysia, and Deputy of Deans from Faculty of Science, University of Malaysia. And ladies and gentlemen, let me show you about our title. Now, I would like to deliver in this mini symposium on current progress of mathematics and natural sciences. The title that has mentioned for the moderator about the rising awareness of hazardous chemical on health risks. This is topic, I think this is related to the global issue. Yeah. If we're talking about the global issue now is how is about the health issue and environmental issue. That's the point. We are as scientists, I think we should know that this is global is very important. Why is very important? Because in our world, there's many products produced based on chemistry. So that's the point. Now, let's move. Okay, this is this is the outline that I would like to presentations about the introduction and risk and benefit of chemical, because we should know also about the chemical, not only risk they have, but there's also benefit in our life. So that's why this is very important. And the third, we'd like to deliver about the human are exposed to chemical, what is the problem, it's this case, and the role of toxicology, the chemical toxicity, to assess all the health effects. And based on my study, I will focusing about the DNA adapt as biomarker risk cancer health effect due to chemical exposure. And the closing for the last, I would like to deliver later on. Okay, next slide. People can expose to chemical at work, in the home, indirectly through the environments. Yeah, that is the world is chemistry industry. Chemicals are used in every product and play an important role in their every life for people around the world. Every day, We are surrounded by hundreds or thousands of chemical products. They are chemical in our food, clothes, tool, furniture, toys, cosmetic, medicine, etc. Let's say from the beginning, we wake up in the mornings, we eat something, we drink something, there's also chemical. That is the point that I would like to stressing and focusing. Is it safe or not? That is also what we would like to deliver based on my research study. However, such product, medicine, fertilizer, pesticide, provide protection for crops and increase the yield, prevent the cure disease, and provide countless other benefits that make life better for people. However, despite usefulness, we know many of these substances can have negative impact on our health and environments. There have been dramatic increase in the use of chemical in recent years. Many chemicals are produced, but we don't know exactly is it safe or not. That's the point also. Many of them mixture or those chemical properties have not previously have been studied and which make prove to harmful the human. Hazardous chemicals are substances that can cause adverse health effects such as poisoning, breathing problem, skin rashes, allergic reactions, allergic sensitization, cancer, and other health problems from the exposure. We are exposed and accumulate the chemical in our blood, in our tissue, but we know almost nothing about this effect of them and how the chemical behave in our body. That's why, based on my research study, I can share you how important is the cancer risk, the impact negative of the substance. Okay. According to Europe stats, in EU, more than 300 million tons of chemical were consumed in the EU in 2018, and more two-thirds of this amount were chemical that classified as hazardous to health. Next, please. So, in this slide, I would like to share to you also about what is risk, what is benefit of chemical, because chemical is very important in our life. So, chemical are like the two sides of coin. One side is benefit for us because chemicals are useful in everyday life, but other side, this chemical also have negative impact on our health in this case. Paracelsus has mentioned distinguish between drug and chemical, drug and toxic, just only those make the difference between drug and medicine. And toxic, I mean that. So the benefit of chemical are used as products, play an important role in our everyday life, like agriculture. We need pesticide, we need also fertilizer. In food industry, we need also to maintain the quality of food additive, as recommended by, like Indonesia, BPOM, the agent for watching and control the food. We have preservatives, flavor, and taste or enhancer is also important in our food. In pharmaceutical product, we need drug, medicine, and cosmetic, and so on. This is the benefit of chemical. But the other side, as I mentioned before, the chemist or chemistry has inherently have hazardous properties like toxic effect, corrosive, and cancer effect, and others could be also environmental effect in this case. So, what should we do in this case? First, we must understand between the things risk and hazards. Risk and hazards depend in the term, depend on the meaning. Risk that mean a probability of hazard occurrence, but hazard is intrinsic inherently properties of matter of chemical to give it a special effect. So between risk and hazard is different in scale. What is exposure? Exposure is occurring when the people have contact with a chemical, either directly or through another substance contaminated with chemical. So do we worry with the chemical? I think we should polite in this case. Yeah, because we cannot avoid the chemistry. Important is the risk of toxic chemical could be ignored if there is no exposure. That means no exposure, no contact, no risk. This is the management, how to manage the chemistry and chemical product in our industry. So if we understand about this one, I think to minimize the problem is how to minimize the risk. The management of chemical is very important and play important role in our society. Okay, next. How to know, to identify the chemistry, this is hazard. Yeah, a material can be categorized as hazard if it has one of the following characteristics like symbol. We just know about the symbol. If we know the symbol and labeling, and we know this is hazard or not, the character of the chemical. Think. Next, move. Okay. This is the symbol of chemistry. Okay. Click. On. Yeah. And then. Okay. Okay. Actually, the chemistry, based on the regulation, international regulation, every chemistry should have the symbol, should have the label. Why is it for? Is it to avoid the misuse and abuse of chemical, to avoid the minimal risk and the minimal effect, the negative of chemistry. So if we know about the symbol, I think we can a little bit save in our manage on chemistry. Okay. Next one. Click. So as I mentioned, humans are exposed every day in the world. Yeah. In our food production, food industry, there is food contaminant, maybe could be. There is food additive, ingredient food, and so on. Chemical compound from in processing, that could be also contain some hazardous chemical. So be careful about that. In smoke, also, of course, we have known, we have identified so many more than 100 hazardous chemical in soft drink, in cafe. There is also some people misuse and abuse of chemical. If that happen, it could be make the negative impact on our body. Okay, next up. So what does the chemical toxicology do? As I am a chemist, I'm doing the research, the toxicology. This toxicology help by providing an evidence-based scientific basis for policies to control or manage chemical, prevent disease, and protect the health. So how the role of the chemical toxicity? And next slide. The role of toxicity as science, as the science of poison. In the past, toxicity as the science of poison, and now the toxicity had step up to study about behavior, mechanism of toxic chemical, and adverse effect of symbiotic chemicals, especially on biological system. It is very useful, the role of toxicology to predicting, assess all the effect of studying the effect related to toxic chemical properties on human and environmental so that the risk can minimize. Okay, next. Ladies and gentlemen, this is a roadmap that I would like to show you how to study about, how to research study about chemical toxicology. The important thing, everything is first the exposure, the source of the exposure. The exposure could be in our food, yeah, media, water, drinking water, beverage, and air pollution. Where the source is this exposure, this from chemical industry and product chemistry, and could be also in our environment in this case. How this chemical get into our body? Yeah, there is exposure pathway. By inhalation, we can export the chemical will enter our body. Yeah, through the ingestion, we eat the food, we drink the water. Yeah, we drink soft drink or the water and so on. This could be the chemical can enter our body. So what the next? Yeah, based on the roadmap study, we can deliver the food, the content chemical in this case, deliver to our body. Next slide, please. Yeah, by the system of ATMA. What is ATMA? This is acronym of absorption, distribution, metabolism, or biotransformation. This is system designed to studying, to investigate it, how the chemical behavior in the living organism. First, when the chemical enter our body, and then chemical molecule will absorb in our cell and distribute in our blood, and then there's importing the metabolism and or biotransformation. The product biotransformation, return to my roadmap, please. Oh, no, return back. Yeah. When the molecule of chemicals will be transported to other, let's say, toxification, that means the product chemistry in our body will be more toxic than before. There's possibility also if the biotransformation helps in our living organism to detoxification, it means the chemical product or metabolite will be eliminated in our body through the excretion. Okay, next. So the important also, what should we know about the hazard of chemical? As I mentioned before, Paracelsus have said, all things are poison, only dose make it not poison. That means the dose make differentiate, distinguish between poison or not poison in this case. Important is the relationship couple dose effect. So as click, please click one more. This is we can find it what the characteristics or the criteria of toxicity of substance. That means LD50, lethal dose 50. Lethal dose is one parameter important to show how the effect of the chemistry. Acute effect, normally we use under LD50 failure. But the problem is, we every day take place and eat and expose to chemical under the LD50. That means there is parameter NOIL, NOIL, no observed adverse effect. It is the low and small doses. It is safe for us. That's the point why chemical toxicity is very important in this case. Okay, next one. This is this is a history about disaster about the chemistry, for acute effect in toxicology. Let's say the Bhopal tragedy, pesticide plant in December 1984, methyl isocyanate released to environmental, 50,000 dead in this case. Minamata disease also take a long time, and then there is 200, 900 people. Okay. Listen, move. Okay, no. Okay. So what is the chronic effects? The chronic effect is based on the study Dole and Petov in 1981. The most important chemical causes cancer, there is comparison in the slide. Yeah, first the food. Peto Endol has mentioned in his book. The first is food nutrition, 35% cause cancer. And the other tobacco, reproduction, sexual behavior, infection, occupational, and so on. Okay, next. So this is data that I found in the website about the cancer in Indonesia, especially in Indonesia. In this top 10 malignant in Indonesia, but we don't know. Yeah, do we have the data? What caused the cancer is in Indonesia? This is also the question. Until now, we don't have the answer in the research during 10 years ago. Yeah, okay, now. But based on international agency research on cancer under World Health Organization has mentioned and classified, there is chemical that we call chemical carcinogen. That means carcinogen that can the chemical cause the cancer. The classification of ERC carcinogen is group 1, that means carcinogen to human based on epidemiological study. Yeah. Group 2E, that means probably carcinogen, that's chemical that probably carcinogen. And group 2B, possible carcinogen to human, but the data is limited. And group 3, carcinogen, not of classification, but we should precaution. And the 4, there's probably safe in this. So how they get the study? How get the data risk? The classification. Okay, let's move. Yeah, this is a sample of. Sorry, I noticed. Okay, this is profile the breast cancer cell, pancreatic cell, skin cancer, human thyroid cancer module, and kidney cancer. How we can identify this cause of cancer? Okay, next one. Based on the study, DNA, we have DNA in our body. Again, that's very important for our human living, human life. But based on chemistry, DNA contains guanine, adenine, cytosine, and thymine as chemistry that have negative charge moiety in DNA. So what is the role in this case for the DNA form to be DNA duct? Okay, next one. DNA formation as biomarkers based on the EIRC study, carcinogen chemical, DNA duct are addition product formed by the covalent binding of all part of chemical carcinogen to chemical-based moiety in DNA. Adduct are formed when activated chemical species, electrophile, positive charge of metabolite binds covalently to negative charge moiety in DNA. Please click on. This is the profile DNA duct in our gene. So what will be happen if there is DNA duct in our gene? Of course, there could be disrupt the system gene in our body. Okay, next. Yeah. Based on the ERC also, they have library, which kind and what kind of adduct will be formed. Yeah. And this is about the binding site of the guanine based on the classification of ERC. Okay, next. In this slide, I would like to show you also, based on WHO, yeah, WHO, World Health Organization, and EIRC has saw the roadmap of how the DNA duct cause the cancer. First, as I mentioned before, if humans are exposed to hazardous chemical and could be metabolite, could be metabolism will metabolize and then transfer to activity. If their detoxification is safe, but if their hazardous chemical is accumulate and reactive, there is something like that, and will be toxification, intoxication. And if it happen, occurring, they will be binding with DNA normal and form the DNA image. And if DNA damage, there's no repair, there's no DNA repair, or DNA repair can slide this one, and then DNA repair could be happen in our body. But if DNA repair is not success the DNA will continue, yeah, because the enzyme is not now about the DNA normal, and DNA they can differentiate between DNA normal and DNA damage. It could be DNA that form neoplasia. That means the first step of the carcinogenesis. This is, of course, this is need for a long time. Yeah, that's why based on the toxicity effect, there is chronic effect that could be cause of risk of cancer. Okay, next. Based on my study, there is a reactivity model. I get the substance like an alpha-beta unsaturated aldehyde. This is compound that we have in food, yeah, in many beverages also. We can find it about this one, yeah. If we are not managed clearly, should be the content of this substance enter in our food. Okay, next one. How do we study? How to detect the DNA adduct? Yeah, we have a study. Yeah, the case study about the DNA adduct formation in vitro study and also in vivo study. We take the urine, blood, and cell and organs. Okay, for in model in vitro study, this is very simple. We can take the DNA based on DNA and reaction with the chemical carcinogen and incubate by certain temperature and also duration of time, and then close we can isolate and we can detect it. Okay, next one. This is a profile what I have done to prove that chemical hazards causes cancer. We can use the red fisher, yeah, and other also species we can use, and then we can take the sample also, yeah. The rat fisher we incubate or we expose with some chemical, and then we can take the urine, we take the blood, we take the cell, and then we can isolate the DNA. After isolate the DNA, we can digest the DNA with enzymes, and then we can close to detect with a method. Okay, next. What kind of method do DNA detect now? So many methods that development now to detect how to prove the DNA adduct. HPLC with detector UV on detector labeling phosphor, something like that. LCM SMS, certified post labeling, ELISA, and so on. So many methods now developed to detect how to prove the DNA adduct form in human body. Okay, next up. This is profile for APLC they have study in vitro. Okay, click. This is APLC program of nucleotide and enzyme digest after we study with in vitro with some chemical carcinogen that we can found in our food. And this, if you see in our slide, there is croton aldehyde adduct. That means this is part of the DNA that interaction between croton aldehyde covalency with DNA. That means with guanine adduct. Okay. The other analysis for DNA adduct, we can use also, as I mentioned before, we can use post method labeling process. Okay, click. This is for labeling process is very high sensitive. We just can take a small, yeah, okay, 1 microliter, something like that. We can identify if the blood, if the cell contain the DNA adduct. That means someone has risked the impact of chemical exposure. My study have also published in journal Carcinogenesis. That's been the journal that very famous in the medicine. Yeah, yeah. And then my study also have proved in many journals. We publish about the development, the method, how to detect the DNA adduct. Okay, next later on. This is also, we can also characterize the DNA adduct, yeah, based on the chemists. Yeah, we can use the instrument like SPLC, NMR to characterize what kind of adduct, and also we can analyze. Yeah, we use the post labeling, and also post labeling we use also by the as detector in FSC, and we can find that's DNA. We can prove that's content in blood sample or in the cell sample. We have published in this case, yeah, in carcinogenesis. This is a very precious journal that adopted to WHO, that ERC, and ERC had also printed some book. They collected the book, the data, the data from DNA study in the world. We are part of them. We have also inserted in the book data set. Okay, next. As closing a ceremony, our summary in our presentation, humans are exposed chemical every day at home, at work, indirectly through the environment. We have surrounded by hundreds of thousands of chemical products. They are in our food, clothes, tools, furniture, toys, cosmetic, medicine, etc. Material can be categorized as hazard if it has one of the following characteristics symbol or hazard. So this is important. The percussion statement is we should have known if the chemicals is content hazard or not. Just we can know based on the symbol or pictogram or labeling. If know about the symbol, I think we can save because we can avoid the exposure, the hazards of chemical. DNA adduct as biomarker, as risk cancer, are addition product formed by the covalent bending of all part of the chemical carcinogen to chemical-based moiety in DNA. That's all what we would like to deliver my experience in our study focus in DNA adduct in chemical toxicology. I hope you can follow me. I hope you can more understand and rising awareness how the chemical hazard is very harmful for us. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Okay. Thank you very much for the interesting talks for Professor Budiawan. Because we have a time constraint, maybe I will give a time for like one question for Prof. Budiawan. Is anybody would like to ask about this one? Yes. Miss Astari, Bu Astari. Silakan.
Oh yeah, okay. Thank you, Pak Ridwan, and thank you, Prof. Budiawan, for your interesting talk. I just want to ask about the DNA adduct that you explained. My question is there any specific genes which are prone to this DNA adduct? Because in biology, we usually learn about the oncogene, yeah, and also tumor suppressor genes, which probably got mutated, and that's caused the cancer. So I just want to know about the correlation between this DNA adduct with the specific genes for the cancer. Thank you.
Direct answer? Okay. Thank you very much for your question. There is no difference. All the gene, yeah, can interact with covalent bonding with chemical carcinogens. Every genes, yeah. DNA adduct basically when there is chemical carcinogen enter to our body, and then the body will be metabolized and will be activated, intoxication, and then Of course, is even this is a small dose. Yeah, as we know, the small dose we can think about the negative. Yeah? But in fact, if the characteristics of the chemicals organ is accumulate, yeah, and they have also site or functional group activity, they have, there could be binding with the DNA, every DNA from gene. So there's no difference between gene, genome, and cell. I think this is my answer. Thank you very much.
Okay, thank you, Prof.
Okay, probably for me, like one last question, it's just a simple question. In the near future, in your point of view, what kind of chemicals we must aware for this risk health? Because nowadays, currently we have like ethylene glycol in our medication, something like that. And also the kind of, food preservative in our food. So in your point of view, in the near future, what should we aware of these chemicals?
Thank you, Paritwan. First is rising awareness. You should now. There's more than 100 new chemical was products in the world. Is there safe? We don't know exactly. That's why study of toxicology. That's the point. Why? Because Indonesia is very limited. The researcher who study about the chemical intoxication. Even there is a medicine faculty I have seen also, they're not so concerned about. But the reality in Indonesia, there is, the cancer incident strike and on and on. So we must concern first, the government should be control what kind of chemical content in our food, in our drinks, in our that's point. So how to study about it? Easy. First is important is labeling all the compound. In labeling, there's content or symbol or pictogram. There's classification that the chemical that hazard classification or not. There is, regulation about that. I think this is good for us. And the point also important for us, don't be routine as daily exposed to us of the chemical. So change, don't use a chemical every day during your life. Change one time with other substance, and then change with others. There is also chemical that's very safe also. You can use the data from baby pom, something like in Indonesia, maybe in Malaysia, I don't know exactly, but there is a control agent in this case. That's one. Thank you very much.
Thank you, Professor Budiawan. The point is risk equals hazards times exposures. That's the main thing. If it's not hazardous, whether you are exposed many times, there will be no risk. But if there's a high hazard, one time exposed, there will be like high consequence or something like that.
No exposure.
Will be no. Yes. Okay, thank you very much for the insightful talks for Professor Budiawan, because the time is limited. Maybe I will close this plenary session in Universitas Indonesia. And can we have a question from do we have question from the University of Malaya? University Malaya, I'm sorry. Enggak. Okay, there are no questions from University Malaya. So maybe I will conclude this plenary session with Professor Budiawan. Thank you very much, Professor Budiawan, for the talks. And I will close this session by saying Alhamdulillah, Assalamualaikum warahmatullahi wabarakatuh, and I will give back to MC Miss Tessa.
Thank you so much, Prof. Budiawan. Before leaving the stage, please stay here for a moment. So before we end this session, we as the appreciation for Prof. Budiawan's time and valuable contribution, may I invite Bapak Dede Juhana PhD to deliver the certificate to Prof. Budiawan. Thank you so much, Prof. Budiawan, Dr. Dede, and also Dr. Ridwan. Honorable guests, ladies and gentlemen, we will continue to our second plenary session. Our second keynote speaker is from University Malaya, Professor Dr. Muhammad Sufyan. Professor Sufyan will present the topics entitled Bioplastic PHA, Waking Up a Sleeping Giant. Without any further ado, I will invite our moderator for this session, Associate Professor Dr. Zul Ilham Bil Zulkifli, from Institute of Biological Science, Faculty of Science, University Malaya. So, Associate Professor Dr. Zul Ilham, you are highly requested.
Thank you. Thank you very much, Ms. Chair Speaker. I would like to start by testing. Could everyone hear me well? Yes. Okay, Assalamualaikum and a very good afternoon. The Honorable Dean and Deputy Deans of Fakultas Matematika Ilmu Pengetahuan Alam Universitas Indonesia, Honorable Dean and Deputy Deans of Faculty Science University Malaya, and rakan-rakan fellow participants of this international symposium. I'm Zul Ilham from University Malaya, and I will be moderating the keynote speech session today, this morning. I will begin by introducing our keynote speaker. Professor Muhammad Sufyan bin Muhammad Anwar received his Bachelor of Science with honors and PhD from University Malaya, Malaysia. He later started his academic career as a lecturer at his alma mater, University Malaya, in 2005. He is currently actively working in the area of bioprocess technology and advanced biomaterial, using medium chain length poly-3-hydroxy alkanoids obtained via bacterial fermentation from local renewable resources. His research group demonstrated its potential application for making hydrogel, bone scaffold, nanoparticles, and innovative biocomposites. His approach on scientific investigation places strong emphasis on equal balance between fundamental and applied researchers. The approach has enabled his research group to contribute over 120 publications in reputable scientific journals, and he has successfully supervised 16 PhDs and 31 master research projects to completion up till now. Through its own project and collaborative effort, his laboratory has secured research funding in the excess of 4 million ringgit Malaysia to date. His research group welcomes multidisciplinary scientific approach and collaboration. Without any further ado, I will welcome Professor Dr. Muhammad Sufyan bin Muhammad Anwar to deliver his keynote speech with the title Bioplastic PHA, Waking Up a Sleeping Giant.
Thank you very much for the kind words, Associate Professor Dr. Zul Ilham. Assalamualaikum warahmatullahi wabarakatuh, and good morning. I think it's still morning. Yeah, respected colleagues from Faculty of Science, University Malaya, and colleagues from Fakultas Matematika dan Ilmu Pengetahuan Alam, Universitas Indonesia. It is indeed an honor to be here and to share with you some perspective on a subject that has been my professional vocation until now. The title of the keynote is Bioplastic, Waking Up a Sleeping Giant. Our agenda for this keynote is as follows. I'll give you some scenario on global plastic pollution, followed by current affairs of bioplastic, and then bioplastic research at University Malaya over the years, and finally the way forward. Next. So scenario on global plastic pollution. Next. All right. So ladies and gentlemen, this is our problem, our very pressing problem globally now. Each year, 5,000 tons of plastic are discarded to the environment, and out of these, only 9% got recycled, right? Almost 80% are discarded, all right? And this problem of plastic, the synthetic plastic, the petrochemical-based plastic, right, is becoming a major problem globally now. It's everywhere, all right? As you can see later, nowhere is being spared from this problem. So it projected that by year 2050, plastic would contribute about 15% of global carbon dioxide emission. Next. So our over-dependence on synthetic plastic, the petrochemical plastic, will make us pay a very heavy price in terms of greenhouse gases emission, right? And this, of course, will culminate in climate crises and unsustainable research consumption. In terms of the solid waste, the plastic waste, it is estimated that 13 million tons reach the sea each year in the form of bulk, micro, and nanoplastic. So this, our dependence over the decades to plastic has caused this problem that we observe now. Next. Right. So the consequence of this from the waste, say, for example, when you have plastics that are being fragmented and the chemical compounds of this plastic leach or dissolve into the ocean, you have the acidification of the ocean. Of course, these have detrimental effect to the ecosystem, the ocean ecosystem itself. Then you have the food chain contamination by micro and nanoplastics. Microplastics, for example, has been found everywhere. Recently, last year, it was detected in blood, it was detected in lung tissue, of course, in stool, and up to our south and north pole, right? And studies have shown that this microplastic is the accumulation point and transmission vehicle for heavy metals, viruses, pathogens, and antibiotic-resistant bacteria. These are being shown in studies. And back to the earlier one, some preliminary studies also indicate that by ingesting this microplastic, it could cause detrimental changes on genetic resources and animal behavior. These are also reported studies. Next. So how does this bulk microplastic get to being in the environment? So for example, you have the large plastic being disposed on terrestrial or ocean, and this through the action of wave or abrasion, the mechanical forces, and also the more important is the sunlight. All right, you have photofragmentation from this plastic along with the mechanical forces just now. And then the photo dissolution will get these chemical compounds or additives from the plastics into the ocean or into terrestrial. And then this can also move on to become nanoplastics, undergoing the same process, similar process, and you will get a dissolved organic carbon from plastic in your environment. Next. Of course, having given you this overview of the problem, some possible solution, of course, the obvious one is to reduce the consumption, our consumption of petrochemical plastic, and to improve the chemistry of recycling from what it is now, to put in place legislation and social policies regarding the use of synthetic plastic. And the most attractive option is to come to this alternative, which is a bioplastic. Bioplastic represent a very attractive option because it is a form of a circular economy from raw materials, from its production, usage and post-usage, all in a closed loop system. Next. So what is the current affairs of bioplastic that we have now? Next. So the bioplastic we're interested in is this kind of bioplastic. Bioplastic that came from bio-based resources and it's also biodegradable, right? So it's bio-based and it's biodegradable. For example, polylactide, polyhydroxy alkanoate, which is the one that we're talking about today. Polybutylene, PBS, can't remember what's the S for. All right, and then you also have bioplastic that are made from bio-based resources, but they are not biodegradable. For example, polyethylene, polyethylene terephthalate, trimethylene terephthalate, PEF is polyethylene furanoate. Those kind of non bio-based, but they are not biodegradable. Of course, you can also have bioplastic made from fossil fuel, made from petrochemical sources, but they are biodegradable, such as PBAT and PCl. And then you have the bioplastic that from fossil fuel, but not fossil sources, but not the conventional plastic, right? So our interest is this one, the plastic that are made from bio-based resources and are also biodegradable. Next. Bioplastic are already there in our everyday life, right? It is there in your packaging for your food, your cutlery to eat those foods, right to your cosmetic products, right to your office equipment. It's there already in our everyday life. Next. And what makes it a very attractive option is that the end of life option for this bioplastic is they are closing the loop, right? So for example, for biodegradable and compostable plastic product, the biodegradable bioplastic, you have the option of collecting this waste and then use it to produce some energy, some fuel, and then if you compose them, it can be used to generate a feedstock to produce more bioplastic later, and then to make new items. And if you have a bioplastic that is bio-based but not entirely biodegradable, you can have the option of mechanical recycling, where you collect them, use the waste for energy production, and then or then go to the recycling plant to get material or raw material to be recycled, to be reused in the manufacturing of new items. Next. Let's look at the global production capacity of bioplastics. So if you look at this part, right, these two parts, in last year alone, 1.1 million ton of bioplastic, biodegradable bioplastic were produced. And this, in the next 5 years, this is expected to increase at least 3.5 million tons. So 3.5 times increase from what it is now. As compared to the bio-based but non-biodegradable plastic, it will only increase about 2.7 million ton in the next 5 years. So you can see there's a huge increase, more than 3 times for biodegradable plastic. Next. And where are all this happening? Global bioplastic production capacities is all happening in Asia region, right? There's supposed to be, I think, a map there, but it doesn't appear for some reason, right? So in year 2022, last year, 41% bioplastic production capacity in Asia, and expected to increase to 63% in the next 5 years in Asia. How about biodegradable bioplastic? Next. Similar trend. Last year, it was 40% capacity production by Asia, and in the next 5 years, it will increase to 67% capacities of production, again concentrated in Asia region. Right. Next. So which market segment this biodegradable bioplastic captures? So 55% of this biodegradable bioplastic will be in demand for packaging, right? And in other market segment like agriculture, coating, electronic. But as the years in the near future, it is expected other market segment also will increase concurrently, like packaging market segment. Next. So in terms of material, in 2022, right, there are two types of biodegradable bioplastic that drive this production: the PHA, the subject of our discussion today, and the PLA. But if you look at the PHA, right? Last year it amounts about 100,000 tons production, and in the next 5 years it is expected to increase to 550,000 tons. This is more than 5 times increase in the production and also demand for PHA. Next. And in terms of production material type, you can see that from the total bioplastics in 2022, 50% of it is biodegradable and about 50% is also bio-based but non-biodegradable. And 4% is PHA and 21% PLA, polylactide. And in the next 5 years, we can see that the biodegradable component, the segment biodegradable, will increase to 57%. And then PHA will increase by 5% to 9% and PLA to 38%. Next. So, but I would like to focus our attention on the biotech polymers such as PHA, which are driving the growth of biodegradable bioplastic. Polyhydroxyalkanoates is the long name for this, but for the sake of simplicity, we'll just call it PHA. All right. So PHA is a natural polyester. It is present in microorganisms and in higher animals. They have their physiological function in the living organism. All right. And because of that, PHA is bio-based. They are biodegradable. They are biocompatible. And even if accidentally consumed by marine or terrestrial animal, they are safe. Unlike when this animal consume synthetic plastic, it can, it can become hazard to them. And the properties of PHA ranging from crystalline, brittle and hard to amorphous, rubbery and soft, so and everything in between. All right. So it's a very wide and far kind of properties that you can get from PHA. Next. Now, natural PHA itself has more than 500 different moieties. All right. So this is natural PHA, not yet the one that you do chemical modification or whatsoever. And they have comprehensive combination of what you can do towards the end of life of this material. A wide option for processing of this PHA, all right, from compounding to functionalization, blending that doesn't have to involve melting, right? Chemical modification, of course, and the use as thermoplastic, thermoset, elastomer, lubricant, glues, additive, I think is covered there. So it's there. Those are the things that you can use PHA for. And these are some of the conventional products based on natural PHA that's already in the market, right? Some non-conventional use of PHA, they have been used for animal feed additives, cell regeneration, right? Denitrification, and if you are a soccer fan, in fact, FIFA have approved the use of PHA in their turf fill-in, in fact, all right? This, believe it or not, this LP is made entirely of PHA, unlike the usual one made from vinyl. So next time your music is also biodegradable, right? So the LP is made just last year in the UK entirely from PHA. Next. All right, where is this producers? So last year, 28 listed PHA producers worldwide. In Europe, these are some of the companies or manufacturers in Europe. In the Americas also. In Asia, we have just a sample of producers: Kaneka in Japan, Tianan Biologic Material in China, Blue PHA in China. How about Southeast Asia? Only one, which is CJ Bio. This is from the arms of Cheiljedang Corporation from Korea. And in 2022, CJ Bio newly commissioned facility now is operating out of Pasuruan, Kabupaten Pasuruan, Jawa Timur, Indonesia. This is the only, as I can show you later, next. This is the only facility in the world, in Pasuruan facility, that produce amorphous PHA, which is the the focus of our discussion, the amorphous PHA marketed as PHA Act. All right, this is the only company. The rest of the other company produce a hard type of PHA, the crystalline type or semi-crystalline type of PHA. And this PHA Act is certified as biodegradable for industrial composting, terrestrial and marine composting, and it's also home compostable. You can compost this at your house, at your home. And CJ Bio correctly target the largest segment of the market, which is the packaging, where more than 50% of single-use plastic is. All right, CJ Bio targets that. So next 5 years, because this facility just operate, I think, in the last quarter of last year, right? So the next 5 years will be interesting to see if CJ Bio is capturing the market for this and dominating it, the market for amorphous bioplastic. Next. So the amorphous PHA, these are some properties of it. It's biodegradable, as mentioned. It's a polyester, it's thermoplastic. It is sustainable because you make it using microbial fermentation from renewable resources. CJ Bio use genetically engineered microorganism for the fermentation of its amorphous PHA in Pasuruan. Okay, and of course the option for processing of this PHA, you have a wider option. Some probably I omitted here. And of course, the natural PHA and its derivative can become platform materials to get more exotic and innovative materials. Next. So there is the scenario. What is the current state of affairs for bioplastic? So what about bioplastic at University of Malaya over the years? So amorphous PHA in University of Malaya is the medium chain length polymer. This is the same PHA that CJ Bio is producing here in Pasuruan. All right, and at University of Malaya we've been doing this since mid-1990s. Right. This is just some photo from our lab. This is the microbe, the Pseudomonas putida, where it's already very fat with PHA. PHA is intracellular. So you can see these PHA granules, and when you extract it out, that is how it looks like. It just look like ordinary plastic, right? But it's biodegradable. Next. So we focus on both PHA for bulk application, but since the early 2000, we also look at the niche or specialized application for PHA at University of Malaya. Next. So how do we make it? So it's simple. You can use palm oil, palm kernel oil, and the fatty acids from this oil, right? Or you can use palm oil meal effluent. You can use sugars from empty fruit bunches, all right? The fermentable sugars, hydrolyzable sugars. Feed it to the microbes. Here at UCMLI, use Pseudomonas and Diphtheria. You must remember, Indonesia and Malaysia alone, these two countries, they provide the whole world demand for palm oil. All right. So we have the substrate for this right in our backyard. All right. Indonesia and Malaysia alone provide the world demand for palm oil. And from here, you can make the PHA. All right. The amorphous PHA, and then from there, once you extract, you can do modification, right? Or functionalization using innovative techniques, enzymatic, chemical, the traditional chemical techniques, also no chemical even. And you can turn this into things like bone scaffold, composite, hydrogel, stimuli responsive material, self-cleaning film, nanoparticles, electroconductive material, and proton exchange. All of these which have been done at University of Malaya. Next. So the recipe to make this is simple. So if like petrochemical plastic, you have to drill the ground and get the oil out and everything. Here, all you need is producer microbe, which is a lot, abundance, all right, in our environment. Renewable feedstock, waste, or if you want to use something else, it's also possible. And then all you need to get is optimal condition, then you get your amorphous PHA. It's simple as that. And at University of Malaya, our spectrum of research cover almost entirely the area of fundamental studies, innovative bioprocessing, and application demonstration, and everything upstream and downstream. Fundamental studies also, we particularly interested to understand, for example, the behavior of packing of this PHA, right? The packing, because the packing will determine how it behaves at interfaces later. If you say, for example, if you composite it with perovskite, if composite it with metal, for example, right? Next. This is just some micrograph. You can see again the PHA. They've been fed with the feedstock, like in this case, fatty acids of palm kernel oil, and they get fed with PHA. Next. So this is some PHA, how it looks like after they have been extracted out. Okay. Next. This is the general structure of PHA. The amorphous PHA, just like what the CJ Bio is producing, there's polyester, and this side chain, the monomeric composition, is the one that you can change, as I show you later. And once you change this, it's almost infinite way that you can change this by microbe. You don't have to do hard chemistry to do it. Microbe is a good chemist. So you can, and because you can changing this, you can manipulate easily the properties of PHA. Next. So this is from our published work. Say, for example, I use Pseudomonas and I use Delphtia, and I feed these microbes using C12, for example, lauric acid, even chain fatty acids. I get different type of, some type of monomeric composition. But if I feed the same carbon source to Delphtia, I will get something different, right? Then these differences that give unique properties to PHA. Next. So again, if I feed them odd chain fatty acids, again, something else. C11, for example, undecanoic acid. So I get this kind of composition. Again, for Delphtia, it gives me entirely different composition. All right. Next. And I can use even unrelated carbon source like glucose, for example. I feed them Pseudomonas glucose, I get that hydroxyoctanoate, hydroxydecanoate, hydroxydodecanoate, right? But if I put glucose, I give glucose to Delphtia, it doesn't produce all that. It produces only 3-hydroxybutyrate. This is the hard PHA that all the other companies are producing in the world except CJ Bio. Okay, so you can see that by changing the organism, by changing the feedstock, limitless possibilities that you can get. Next. Of course, as I said earlier, by manipulating the composition of PHA, say for example, again using the Pseudomonas and Delphtia, you feed C12, you get different properties in terms of molecular weight. You can see that, all right? In terms of polydispersity index, in terms of thermal properties, the melting temperature, the degradation temperature is different in this case, all right? And then you have the crystallinity is different. So you can see that the one that's produced by Pseudomonas, even though the same carbon source, right, is very much less, it's amorphous as compared to the one that's produced by Delphtia. Next. So what are milestones of applied PHA? I didn't put the fundamental one. Of course, there are important discoveries in terms of fundamental PHA that we made at University of Malaya, but I think this is outside the scope of this keynote. So the first demonstration is 1997, where amorphous PHA is produced from palm kernel oil. All right, palm kernel is not so valuable like palm oil, so it can be used as feedstock for this. And we demonstrate that amorphous PHA can be produced. But as any other research, there are times just long gestation time for discovery. So 10 years only then, or 11 years only then, you make some, it depends on whether you have funding, whether you have good human capital, right? But as I show you in a short while, there are short period of time where we made fast and exciting discoveries in short while. So 2011, after the first demonstration of amorphous PHA production, we showed how thermal decomposition, the control can be used to produce oligomeric PHA with the plasticizer in mind, you know, the potential to be used as plasticizer. And the next year we show that PHA can also be produced in vitro using a single enzyme under acoustic wave condition, all right, under ultrasound. And all this has been published, right? All these milestones has been published, and a few of them have been patented, in fact. Next. And then 2012, 2004, this is what I meant. So within a short period of time, when there are good funding, when there are good human capital, good brains that work on it, you get some kind of important milestone, some kind of important stride. So we demonstrate that PHA and its oligomers as plasticizer in PVC. We show how easy it is to functionalize a single step enzyme functionalization of PHA. All right. And again, we manipulate how to in terms of solvent and mixture, how to increase the yield of functionalization. And then in 2014, we demonstrate that PHA can be used for smart material like pH responsive and shape memory hydrogel, right? Next, 2015, again, very short period of time. We show in biomedical application, PHA promotes angiogenesis and collagen disposition during wound healing in rats, right? And 2016, we show that if you use PHA, you can get emulsion at nanoscale, right? At nanoscale. And this is achieved simply by phase inversion, a very low energy technique, by simply inverting the phase where this emulsion will appear, right? And then 2017, we show that it can be used as composite anode in microbial fuel cell, right? Then 2017, we show the nanoparticle that we get from the polyhydroxyalkanone. So this has also been published in a journal. Tissue engineering for 2017, where PHA is composited with hydroxyapatite, and it shows a good growth for cellular cell that become bones later, all right? And then some follow-up studies on nanoemulsion. And then we show that PHA itself, because of its a polyester, is a very hydrophobic material, right? We turn it into amphiphilic material by simple functionalization with this kind of, and we actually work out the mechanism that how it works, right? And then 2018, we use the microbe and the in vivo depolymerization to get platform chemicals from PHA. Next. Again, some fundamentals, some work on bone marrow stem cell, where we show that PHA is biocompatible with bone marrow stem cell. Some continuation of work on microbial fuel cell. And then 2019, again, PHA is shown as a good in composition with carbon nanotubes, right? It becomes a good proton exchange membrane in microbial fuel cell as compared to the Nafion. It is much better than Nafion, which is conventionally used in microbial fuel cell. And then again, we make porous amphiphilic biogel using simple methods in 2020. Next. Again, we demonstrate the utilization of real wastewater to generate electricity from our work with a PHA microbial fuel cell. Again, modifier for electrodes for both cathodes and anodes in microbial fuel cell. And then last year, we again demonstrate how PHA can be used when it's grafted with PMA film for photocatalytic water treatment, right? Next. Again, some continuation from functionalization work of PHA under ultrasonication. This is in press this year, how we use, this is a demonstration of self-cleaning coating using PHA. Ongoing this year is PHA perovskite. We want to have a selective proton exchange membrane, meaning that proton will move in one direction. It's good if you want to purify acidic water, for example, right? And the amidation of PHA, which potentially used in a lot of other applications, right? And coming soon, why I say coming soon, depending on whether we get funding or not. As any good research is, whether you get funding or whether you get a good brains to work on it, all right? Is a sustainable closed loop high cell density PHA fermentation with a very small footprint production process. 2024 again is still something that we contemplate, right? The last one is the way forward, right? What is the way forward? Next 5 years will be critical, as I mentioned earlier. CJ Bio is out there because it's just operating. We have not yet numbers. How many tons CJ Bio facility is currently producing? Probably by the end of this year, we will know. But if they do, they will capture the market for amorphous species. Remember, amorphous species has much more potential compared to the usual, the crystalline or the hard PHA. But the main challenge for PHA in general or amorphous PHA is the total global manufacturing capacity. But this is just a matter of time. More and more, if more and more companies are opening up their facilities, moving into producing this amorphous PHA, this capacity the gap can be easily closed. All right, so it's just a matter of time. So the giant that I'm talking about in the title to be woken up is this, the amorphous PHA, where the innovative use of this amorphous PHA is limited only by our imagination. And CJ Bio have seen this, and they are putting their money on it. They know they might score something there. But these users with fast-paced scientific and technology advances will again close the gap very rapidly in the next 5 years. And this is where and Universitas Indonesia can play a role as innovation and solution provider in terms of this. The other giant is this region, all right, the Southeast Asia region. Remember that Indonesia and Malaysia alone provide the whole world with the palm oil and its products, right? So there is a huge opportunities for both countries to become a global player in the production of this type of material. We have the location. We are situated right in the region where plastic manufacturing for export, the facilities are all around us, okay? We have abundance of bioresources, palm oil surplus, all right, palm oil waste that you can use, low transportation costs because it's in our backyard, right? We have human capital. We have competitive costs if we are going to sell this polymer as raw material. It doesn't have to be finished material, just sell it as raw material, all right? We can make money, the country can make money out of it. And then the circular bioeconomy opportunities that come from this biomaterial, bio-based, biodegradable material, and of course the incentive that we can get if you want to become a bio hub for this kind of endeavor or enterprise, all right? So I think with that, I thank you for your attention. Thank you very much, colleagues from Universitas Malaya and Universitas Indonesia. So we welcome a collaboration, as mentioned earlier by Dr. Zulilham, a multidisciplinary and efforts on this, all right? So with that, I thank you.
Thank you. Thank you, Professor Dr. Muhammad Sufyan Muhammad Anwar, for the insightful keynote speech about his bioplastic research. As he's mentioned earlier, his research group welcome collaboration and partnership in his area of research. I'm now opening the floor for question and answers from the participants. I'm now opening the floor for question and answers from the participants for Professor Dr. Muhammad Sufyan. So maybe I will start the ball rolling. So Prof. Sufyan, you mentioned that bioplastic or its precursors could be a potential export for Malaysia and Indonesia, right? So what would be the challenges in exporting it? Will there be competition from other kind of feedstock? As you mentioned, we will use palm oil residues, right? Can you explain more about that?
Thank you, Dr. Zul. I think that's a very, very good question. One, we need to understand that if you use palm oil or palm kernel oil or any oil-based kind of feedstock, these are highly reduced feedstock in terms of its chemistry, right? And it can, you know, it is the best feedstock that you can use to generate a lot, a high yield of PHA. One, all right. And the challenges is actually to get this feedstock fermentable, all right. To get, if you use palm oil, it's readily fermentable as long as you have the right microbes. And of course, in terms of if you want to sell this PHA, strategic alliances with key players of the world, you have to make. The government or the industry from both countries must take that leap and establish alliances, all right, smart partnership with players, particularly the conventional plastic players globally. All right. Thank you.
Thank you, Prof. Sufian. He will take strategic partnership in order for both countries to bring it up higher to the next level. So is there any further question from Universitas Indonesia?
Yeah, I have questions. Thank you very much for your time. Very interested, Professor Sufian, for your presentation. My question is about the challenge because you said that you use palm oil, yes, part of the component palm oil. So far, how is the challenge? I mean, the process to find the the substance in palm oil to create, to set up this biofuel. So far, I don't know, understand about it because this maybe it's very complicated or it's easy. What is challenge about it? Thank you very much, sir.
Terima kasih Pak atas soalannya. Jadi untuk menggunakan palm oil atau palm kernel oil tidak diperlukan. There's not necessary to make further amendment or further modification to it. You can use as it is. All right. Even the palm oil meal effluent, all right, you can use it as it is to get the PHA. So in that way, the feedstock is already ready to use kind of feedstock. Of course, I think I would like to draw the attention because some proponent, some exponent could say that, but this palm oil, this is a plant oils, these are food oils, right? And you use it to make bioplastic. How do people feel about it? You see, that's why for bulk application, you can target the production of PHA using waste, right? And there's no problem. People are not becoming so sensitive when you use waste to produce bulk application PHA. But for PHA that is used for very high-end uses, biomedical, for example, energy sector, for example, it's more palatable to people to accept that some food oil is being used to make devices that save life, right? So we must be clear on, say if you want to produce packaging material, you can use sugars from empty fruit bunches, EFB just now, and nobody says anything about it. But if you use palm oil, some people might say something. But if you use palm oil to make PHA, to make medical devices that save life, or in energy sector, I think it's more palatable or more acceptable to people rather than, again, because it's niche, it's very specialized. You don't need to produce it in bulk as what packaging application would require. So thank you, Bapak, for the question.
Thank you.
Thank you, our counterparts from Universitas Indonesia for the question. So, we have one more question from.
Okay, I have one quick question. Thank you, Prof. Sufian, for the very interesting talks. I have one question, not the scientific question, just technical question. I think we all know that the European Union or the European people are boycotting the palm oil product. So if the PHA coming from the palm tree or palm oil, will it face the same problem as the palm oil is facing in the European country?
Thank you, Prof. Azhar, for the question. If they boycott or if they boycott the palm oil, one thing, first, we must up our lobby game, which of course both countries are doing, all right? The palm oil lobby. Everything can be lobbied. So, and companies, huge companies like Nestle, they cannot live without palm oil. So we're going to be safe for a good number of years, right? All the food companies, all the cosmetic companies, they need palm oil. There's no other oil that can compete, even close to palm oil. Soybean cannot compete with it. Peanut oil cannot compete with it. Palm oil is still the mainstay of many industries, oleochemical and everything. If they boycott palm oil, we turn palm oil into something that they cannot say no to, which is PHA, right? It doesn't matter. We have surplus of PHA. We can produce it from palm oil. We can produce from waste. For whatever that you want, even it's not unrelated substrate, you can get it. Maybe they can say no to palm oil, but I cannot say no forever to something that we will need in many sectors, important or advanced sectors. So I hope that answer your question, Prof. Thank you.
Thank you, Prof. Sufyan. I believe that answer conclude our session for today. And I would then pass the mic to our Miss Chair Speaker in Jakarta. Silakan.
Thank you so much, Prof. Muhammad Sofyan, for such a very interesting topics. So before we end the sessions, as our appreciation for Prof. Sufyan times and valuable contributions, may I invite Pak Dede Johanna, PhD, to kindly deliver the certificate to Prof. Muhammad Sufyan. The committee will be displaying the certificate on the screen, and the soft file will be delivered to Prof. Sufyan's email accordingly. Thank you so much once again, Prof. Muhammad Sofyan, Dr. Dede, and also Dr. Zul Ilham. Ladies and gentlemen, we have now come to the end of the first half of the mini symposium. We hope you found this morning's presentations informative and also useful. We will now have a lunch break first, and then we will be coming back at 12 p.m. Indonesia time and 1 p.m. Malaysian time. So the next session will be held in this Zoom link. So you can just stay in this Zoom link, and then there will be 5 breakout rooms consist of mathematics, physics, chemistry, biology, and geology. So every one of you could just choose which breakout rooms that you want to see in the next sessions. So thank you and have a nice break. Assalamualaikum warahmatullahi wabarakatuh.
Tiap bangun sebelum kuliah, saya masih ngerasa gimana gitu bisa keterima di MIPA UI. Sama seperti mahasiswa baru lainnya, saya tinggal di asrama UI. Sarapan bareng teman di kantin favorit saya. Saya suka banget nih sama yang namanya kegiatan mentoring. Ada grup kecil, mahasiswa senior, dan kita ngebahas pelajaran yang masih kurang kita pahamin. Saya juga bisa tanya langsung ke dosen kalau emang masih ada hal yang sekiranya saya kurang pahami. Di UI ada kuliah lintas fakultasnya loh. Kamu bisa pilih apa aja. Ini asik, kita jadi bisa tahu di fakultas lain tuh belajar apa sih teman-teman. Ada soal bahasa, soal psikologi, soal hukum, dan lain-lain. Kalau saya, maunya jadi ahli mikrobiologi. FMIPA ini, fakultasnya gede banget. Saya sangat bangga sekali. Bangga bisa diterima di sini. Nama saya Aul, saya dari Bandung, Jawa Barat.
Matematik adalah ilmu yang mempelajari angka, konsep, dan pembentukan formula yang didasari oleh logika. Sehingga tujuan dari program studi matematika ini adalah menghasilkan lulusan yang berpikiran logik dan dapat membuat kesimpulan yang dapat diterima oleh semua orang.
Departemen Matematika FMIPA UI memiliki konsep penelitian dan pusat studi yang digabungkan sebagai bagian dari pembelajaran bagi mahasiswa. Beberapa di antara lulusan kami yang baru lulus misalnya, bisa langsung mendapat acceptance letter dari universitas di luar negeri melalui jaringan narasumber-narasumber tersebut.
Banyak anak SMA yang mikir kalau matematika itu soal ngitung, dan ngitung. Dulu gue juga mikir kayak gitu. Tapi setelah gue masuk matematika UI, pikiran gue dibuka. Matematika itu bukan soal ngitung, dan ngitung. Kalau misalnya dianalogikan sebagai bahasa, matematika itu adalah bahasa alam semesta. Dan kita, mahasiswa matematika, sedang berpuisi dalam bahasa itu dengan kalimat-kalimat logis kita.
Bidang fisika merupakan bidang yang sangat menarik. Dia dapat menjawab dua pertanyaan yang sangat mendasar di alam semesta ini, yaitu apa penyusun alam semesta dan bagaimana mereka bisa berinteraksi. Jika kedua pertanyaan tadi dapat dijawab, maka manfaatnya bagi umat manusia sangat besar.
Kami para peneliti di Departemen Fisika melakukan beberapa penelitian di bidang energi melalui pemberdayaan teknologi nano, penelitian di bidang antimicrobial material, dan juga perkembangan instrumentasi fisika di bidang bioteknologi.
Mungkin banyak orang yang menganggap kalau fisika itu cuma berisi kumpulan-kumpulan rumus yang nggak ada kaitannya sama hidup mereka. Tetapi sebenarnya kalau misalkan kita dalemin lebih lanjut lagi, itu sebenarnya merupakan suatu ide-ide yang bisa menjelaskan fenomena-fenomena alam yang ada di sekitar kita. Dan jikapun kita kreatif, kita bisa memanfaatkan persamaan-persamaan tersebut untuk mengubah hidup dan dunia kita menjadi tempat yang lebih baik. Jadi teman-teman, jangan ragu untuk bergabung bersama kami di Departemen Fisika FMIPA UI.
Begitu luasnya manfaat bahan kimia, tapi kita juga perlu memahami bahwa bahan kimia itu juga memiliki aspek risiko ataupun bahaya. Manfaat maupun risikonya tentunya kita harus pahami bersama. Untuk memahami lebih jauh tentang sifat dan juga manfaat bahan kimia ini, tentunya kita perlu mempelajari, melakukan studi tentang ilmu kimia ini, dan dalam hal ini Departemen Kimia Program Sarjana FMIPA Universitas Indonesia menyediakan memfasilitasi hal tersebut.
Pada dasarnya riset di Kimia UI ada 3 kelompok besar, yaitu kelompok yang mewakili bidang biokimia dan organik, kemudian kelompok 2 yang mewakili bidang kimia anorganik, kimia fisik, dan kimia analisa, kemudian yang ketiga riset terkait dengan kajian risiko bahan kimia.
Setelah saya masuk jurusan kimia, saya bisa menganalisis dan menemukan bahwa ternyata kimia berpotensi untuk meningkatkan perekonomian Indonesia. Indonesia masih mengimpor bahan kimia. Jika Indonesia memiliki industri kimia sendiri, maka tentunya devisa negara akan bertambah.
Kadang-kadang kita berpikir bahwa satwa ini tidak ada gunanya. Misalnya saja, semut. Padahal Bapak Ibu sekalian, ditemukan semut yang dapat menjadi pestisida. Pestisida itu sekarang bisa dilakukan dengan misalnya menemukan spesies semut yang dapat menghancurkan penyakit.
Setelah saya masuk biologi UI, itu berasa banget bedanya. Jadi kita tidak didorong untuk menghafal nama-nama Latin itu mulai dari tumbuhan, hewan, baik sampai mikrobiologi. Kita diajak untuk merasakan langsung, mengamati langsung bendanya seperti apa, karakternya seperti apa, sehingga dengan berjalannya waktu kita bisa langsung kenal, oh ini tuh dia, tanpa harus menghafal sedetail itu.
Penelitian geografi di Departemen Geografi itu difokuskan kepada penelitian tentang mitigasi bencana. Penelitian geografi itu tidak terlepas dari aspek fisikal geografi, kemudian aspek manusia, dan sebetulnya yang terpenting adalah pemodelan spasial dengan software-software GIS dan remote sensing.
Geografi itu belajarnya luas banget. Geografi mempelajari tentang interaksi antara manusia dengan lingkungan dan bagaimana hubungan timbal balik antar keduanya.
Program Studi Geoscience FMIPA UI merupakan program studi yang secara spesifik ditujukan untuk memenuhi kebutuhan tenaga ahli di bidang pekerjaan antara lain industri minyak dan gas, pertambangan, energi geotermal, oseanografi, vulkanologi, dan sebagainya.
Hai, saya Aul dari Bandung. Nih, kampus kebanggaan saya, FMIPA UI.
Saya Cindy dari Purworejo, kampus FMIPA UI adalah kampus kebanggaan saya.
Halo, saya Sasa dari Pontianak. Ini kampus saya, FMIPA UI pilihan saya.
Saya Ilham dari Jakarta dan saya bangga bisa menjadi bagian dari FMIPA UI.
Saya Gea, saya berasal dari Depok, FMIPA UI, kampus kebanggaan saya.
Halo, saya Tatiana dari Jakarta. Saya bangga masuk FMIPA UI.
Hai, namaku Huliani dari Aceh dan saya senang kuliah di FMIPA UI.
Halo, saya Kalis, saya dari Pontianak. Saya Henry, FMIPA UI pilihan saya.
Hai, saya Sarah dari Jakarta dan ini adalah kampus kebanggaan saya.
Mahasiswa dari 34 provinsi di penjuru Nusantara, berbagai suku bangsa, bersosialisasi, bersatu, belajar, dan tumbuh bersama di fakultas kebanggaan mereka, FMIPA UI.
Air buat bikin stereo. Jangan mau dulu